Problem number 16. Evaluate this limit right here. Limit x goes to 1 of this expression. Note that there's an f of 3x to the 1/4. What is f? We aren't told explicitly what f is. We're just told some facts here about f. F of 3 is 2. F prime of 3 is -8. Okay, our first attempt here might be to simply substitute in for x. X is equal to 1 and see what we end up with. That's always a good first choice, just to see does simple substitution work here. When we substitute in x is equal to 1, we would get 2 times 1 to the 4th minus f of 3 times 1 to the 1/4 power all over 1 squared minus 4 times 1 plus 3. Okay, so this would be 2 minus f of 3 times 1 to the 1/4 would be f of 3. That's also 2 over 1 minus 4 plus 3. And a bit of thought there should convince you that this is 0 over 0. So we have a 0 over 0 indeterminate form. Let's use L'Hopital's rule here. So L'Hopital's rule, in order to apply L'Hopital's rule, you need to take the derivative of the top and bottom separately. The derivative of the bottom, that should be pretty straightforward, 2x minus 4. The derivative of the top would be 8x cubed minus, okay, now we have to use a little bit of chain rule going on here. So it's going to be f prime of 3x to the 1/4. So take the derivative of the outside function, leave the inside function alone, times the derivative of the inside function, which is going to be 3/4 times x to the 1/4 minus 1. So that'd be x to the -3/4. Okay, so that's an application of L'Hopital's rule. Are we able to evaluate this limit here simply by substituting in? I think we can now. So let's try to plug in x is equal to 1. 8 times 1 cubed minus f prime of 3 times 1 to the 1/4 power times 3/4 times 1 to the -3/4 power. All that over 2 times 1 minus 4. Okay, 8 times 1 cubed is 8 minus f prime of this is 3. So that's going to be f prime of 3, which our chart here tells us is -8, times 3/4 times 1. All of that over 2 minus 4 is -2. And so this ends up being 8 plus 6 is 14 over -2 is -7. So this is a good problem. Can you apply L'Hopital's rule a little bit more abstractly?